particles can have a positive charge or a negative charge. Particles with the same charge repel one another. Particles with opposite charges attract one another. This is because charged particles create electric fields. And electric fields exert a force on charged particles. When there is an electric field between 2 points, we say that there is a voltage between them. Voltage can be thought of as the height of a mountain. Rocks at higher elevations can do more damage. The same is true with voltage. The height of the mountain tells you the energy of each falling rock. The total power is the height of the mountain times the number of falling rocks. Similarly, the voltage is the energy of each charged particle. The total power is the voltage times the number of particles. The number of particles is called the current. In a circuit, the charged particles flow through wires. If the wire is cut, the current stops flowing. All wires have charged particles in them. A battery creates an electric field which pushes the charged particles along. With this setup, if one light bulb breaks, all the lights turn off. With this setup, if one light bulb breaks, the other lights stay on. More batteries will give more voltage. This will cause more current to flow, and the lights will be brighter. The batteries do not create the charged particles. The batteries only create an electric field which pushes the charged particles along. All charged particles create electric fields. However, only moving charged particles create magnetic fields. Magnetic fields exert a force only on other moving charged particles. A charged particle moving in a loop creates a magnetic field that looks like this. A spinning electric charge is the same thing. When a material has many charged particles spinning in the same direction, we call it a magnet. We call one end of the magnet the North Pole and the other end of the magnet the South Pole. The magnetic fields exert a force on the spinning charged particles in other magnets. Magnetic fields can also be created by current through a wire. Reversing the direction of the current causes the magnetic field to reverse direction. By constantly changing the direction of the current, we can cause the magnet to rotate. This is how electric motors are made. All charged particles create electric fields. And electric fields exert a force on charged particles. Only moving charged particles create magnetic fields. Electric fields can also be created by a magnetic field which is changing with time. A moving magnet creates a changing magnetic field. The changing magnetic field creates an electric field which pushes the charged particles. The magnet must keep moving to maintain a changing magnetic field. The changing magnetic field creates an electric field which pushes the charged particles. The magnet must keep moving to maintain a changing magnetic field. This can be done by rotating the magnet. This is how power plants generate electricity. Here, the voltage and current keep alternating direction, so we call this AC voltage and AC current. AC stands for alternating current. A battery creates a voltage and a current which is always in the same direction. So we call this DC voltage and DC current. DC stands for direct current. All charged particles create electric fields. However, only moving charged particles create magnetic fields. Electric fields can also be created by a magnetic field that changes with time. Similarly, an electric field changing with time can create a magnetic field. Since changing magnetic fields create electric fields and changing electric fields create magnetic fields, this can cause a chain reaction. We call this an electromagnetic wave. This is how radios and cell phones communicate. Visible light is also an electromagnetic wave. The only difference is that visible light has a much higher frequency than radio waves. Each color is a slightly different frequency. Electromagnetic waves with much higher frequencies are called X-rays and gamma rays.